Have you ever wondered what invisible force guides the movement of water deep beneath the Earth's surface, impacting everything from your drinking water to entire ecosystems? The hydraulic gradient is the fundamental concept that describes this driving force. It is essentially the slope or rate of change in hydraulic head over a given distance, indicating the direction and magnitude of groundwater flow. This concept is central to understanding hydrogeology because it explains how water moves through porous media like aquifers. Water naturally flows from areas of higher hydraulic head to areas of lower hydraulic head. Think of hydraulic head as the total potential energy of water at a specific point within the ground. It is influenced by the water's elevation above a reference point, called the elevation head, and the pressure exerted by the overlying water column, known as the pressure head. A measurable difference in these heads between two locations creates a gradient, acting like an invisible downhill slope for the groundwater. This gradient is the force that dictates groundwater velocity, in conjunction with the aquifer's permeability, as described by Darcy's law. To determine the hydraulic gradient in a real-world setting, hydrogeologists use specialized monitoring wells called piezometers. By installing piezometers at various locations and measuring the water level in each, relative to a common datum, they can calculate the hydraulic head at those points. Once multiple head measurements are obtained, they can mathematically compute the change in head over the distance between the piezometers. This calculation reveals both the direction and steepness of the groundwater flow. Understanding the hydraulic gradient is invaluable for many practical applications. It is critical for accurately predicting how groundwater will move, which is vital for managing water resources, assessing the spread of subsurface contaminants, and designing effective environmental remediation projects. This foundational knowledge allows us to make informed decisions about protecting and utilizing our hidden water reserves. Ultimately, grasping the hydraulic gradient concept equips us with the scientific lens to visualize and quantify the dynamic flow patterns of groundwater, transforming an unseen process into a predictable and manageable resource. It highlights the interconnectedness of surface and subsurface water systems, reinforcing its importance in maintaining ecological balance and supporting human activity.
If you love learning about water, like, subscribe, and keep exploring with us.